Hi, this is Jessica Dunn, and we're going to continue our discussion on capital budgeting, but we are going to focus on the payback period approach. So let's assume that we're going to be looking at two different projects. Project A costs $42,000 and Project B costs $45,000. Project A returns $14,000 a year for 5 years, while Project B returns $28,000 the first year, $12,000 the second year, and $10,000 in the last 3 years. And so we're going to use this data to look at the payback period approach for evaluating projects for determining which is better. And so if we were to put this on a timeline like we always do in this class, we have project A, put on a timeline, time period 0, we're going to pay $42,000, so it's a negative cash flow to us. And then we're going to earn $14,000 a year for 5 years. And now let's do the same thing for 14,000. Let's do the same thing for project B. Let's put it on a timeline. Time period 0 is going to cost us 45,000. So it's going to cost an extra $3,000 to participate with or to accept project B. At year 1, well, we're going to receive 28,000. Year 2 was 12,000, and for the remainder it's 10,000. Okay, so now that we put it on a timeline, we can see what it looks like. We can use different methodologies for assessing the quality of the project and whether or not it meets the minimum criteria for acceptance. So the payback period method looks at the amount of time it takes to recover your initial investment. So in the case of project A, it looks how many years does it take for you to recoup that initial $42,000 purchase. Project B, how many years does it take for you to recoup that initial $45,000 outlay? Now, the decision criteria is a little bit finicky here. So with the decision criteria, a maximum payback period is determined by management. So a maximum acceptable payback period is predetermined by management. There's no formula that you use to tell you what the maximum acceptable should be. It's arbitrarily determined. Now it may have some basis on actual needs of the company. You know, the management may look and say, well, we know that 5 years from now, we're going to have a tremendous tax bill and we need to make sure that we have enough cash on hand to pay that. Or we know that we're going to have a huge expense 5 years from now and we need some cash available for that. So there may be some reasoning that's grounded in real life, but there's no theoretical approach for setting your maximum acceptable payback period. So once you've set that maximum acceptable payback period, if the payback period that you calculate is less than the maximum acceptable, then you would accept the project. If it's greater than the maximum acceptable, then you would reject the project. So let's go ahead and calculate our payback period. So for project A, we spent $42,000. So our cash outflow was $42,000. Project A. In year 1, we recoup $14,000 of that. So that leaves us with $28,000 left to recoup. In year 2, we recoup another $14,000, which leaves us $14,000 to recoup. And in year 3, we recoup $14,000, so that leaves us 0. So our payback period is 3 years. Now with project B, we spend $45,000 and we recoup $28,000 of that in year 1. So that leaves us $17,000 left to recoup. Now we move on to year 2. In year 2, we recoup $12,000. That leaves us $5,000 left to recoup. But now when we move to year 3, that $10,000, that's greater than the $5,000. So because it's greater, we're going to divide. So just ignore the negative sign, look at it as the absolute value. And we see that it takes 1, 2.5 years. 2.5 years to recoup our initial investment. So according to payback period methodology, Project B is better than Project A because you recoup your initial investment quicker. Now again, it's not got any scientific basis for setting your maximum acceptable. If these were independent projects and your maximum acceptable payback period was 4 years, then you would accept both if you had unlimited capital. If they're mutually exclusive, you would accept Project B. If they are independent, but you have capital rationing, then you would invest in Project B. And if you had any money left over, you would invest in Project A, according to payback period methodology. The payback period method is used by large firms to look at small projects, and it's used by small firms for most projects. It's very simple to compute and very intuitive, but it does have some weaknesses. It is not based on discounting cash flows, so it can't be looked at in a wealth maximization kind of goal. The maximum acceptable payback period is subjectively determined. There's no mathematical formula that tells you what the maximum acceptable should be. It doesn't fully factor in the time value of money, and it doesn't look at any cash flows that occur after the payback period. So let's see how that affects us here. We have 2 projects, Project Gold and Project Silver. So Project Gold has a payback period. It costs $50,000, so 5, 5, and 40 is 50. So it has a 3-year payback period. Project Silver costs $50,000 as well. It returns $40,000, $2,000, and $8,000, which sums to $50,000. So it too has a 3-year payback period. Now, it doesn't look at the timing of those cash flows. So according to payback period analysis, these projects are equal. But whenever we look at the timing of the cash flows within this project, we see that with Project Silver, you're recouping the tremendous majority of your investment in year 1, whereas Project Gold, you're having to wait till year 3. So likely Project Silver is better than Project Gold, but because we're not looking at the time value of money, we're not seeing that that benefit of receiving those cash flows early on in the project's life. Now here's another example of why payback period analysis is limited, because it doesn't look at subsequent cash flows. So here we have Project X that costs $10,000, and we recoup that in year 2. 5 and 5 is 10. So it's a 2-year payback period. Project Y also costs $10,000, and its payback period is 3, 7, 10, so 3 years. So according to payback period analysis, Project X is better than Project Y. But let's see what happens after the 2 years for Project X. After the 2 years, you're only going to receive an additional $1,200. But with Project Y, you're going to receive an additional $7,000. And this $7,000 is not being represented in the payback period analysis because it ignores everything that happens after the payback period. And a better approach is to use discounted payback period. It works the same way as payback period, except we're using discounted cash flows. So with this, we're going to have to calculate the present value of each of these cash flows and then use that to calculate our payback period. So what we're going to do is we're going to say, okay, well, this project costs $100 today. In year one, it's going to return $10. So what's the present value of $10? We said the future value equal to the 10. Our discount rate is 10%. We have 1 year, and our payment is 0. Let's compute our present value, and you get $9.09. Now we have to do the same thing for each of these different cash flows. So in year two, our future value would be $60. That's how much we'll receive in the second year. Our discount rate is 10%. We have 2 years to discount this cash flow. Our payment is 0, so that gives us $49.59. In year 3, we would receive $80. Our discount rate is still 10%, but we're discounting it back for 3 years. Our payment is still 0, and we calculate the present value and we get $60.11. So you see with this, each subsequent cash flow is having a smaller impact because we're having to be discounted back further. So it is giving some consideration to time value of money. The biggest problem with it is it's very time consuming because you have to go back and calculate these present values for every single time period. So let's go ahead and calculate our payback period using these discounted cash flows, so our discounting payback period. This project cost us $100. In year one, we're receiving $9.09. So we're looking at the present value of that cash flow. So that leaves us with $90.91 left to recoup. In year two, we are going to be receiving $49.59, the present value of that cash flow. And that leaves us with $41.32 left to recoup. So we see that in year two, though, we're going to be receiving $60.11, so we divide. That's 0.7. So it's 2.7 years, our discounted payback period. So we recover our initial investment and our capital costs in 2.7 years.